17 whole square. 317 whole square. So one is, if it is A, it is B and it is C. I have to use A plus B plus C whole square. But Pascal gave it for a binomial expansion. Pascal gave it for A plus B power K. There are three terms here. This is the first doubt. A student might get it. What if it is a 3-digit number? What if it is a 3-digit number? This is the first doubt. A student might get it. What if it is a 4-digit number? What if it is a 5-digit number? What if it is a 5-digit number? This is the first doubt. Now see here. Listen, and the second doubt is, see here. Sir, is there any importance for A plus B whole square? A plus B whole square. A square plus 2AB plus B square. A square plus 2AB plus B square. Listen carefully, sir. Listen carefully. All these important key points, we are going to solve it. A plus B whole square is A square plus 2AB plus B square. What is B? B is nothing but the unit digit of a number. B is nothing but the unit digit of a number. B is nothing but the unit digit of a number. So B can be 0. B can be 1. B can be 2, B can be 3, B can be 4. First class, I will go very slow. Once you understand, B can be 4, B can be 5, B can be 6, B can be 7, B can be 8, and B can be 9. Am I right? B is the single digit. So these are all the cases which are possible. A with 9 whole square. There is no other value B can take. B being a single digit, it can take all the values from 0 to 9. It can take all the values from 0 to 9. Now see here. This will become very important understanding, sir. A square 2 into A into 0 and 0 square. A square 2 into A into 1 slash 1 square. A square 2 into A into 2 slash 2 square. A square 2 into A into 3 slash 3 square. A slash 4 whole square. A square 2 into A into B and B square. A square 2 into A into 5 slash 5 square. A square 2 into A into 6 slash 6 square. 7 square. A square 2 into A into B slash B square. 8 square. A square 2 into A into B slash 8 square. 9 square. A square 2 into A into B slash B square. Why am I writing all this? This is something which is very, very important to me. Very, very important to me. See here. B is the unit digit. So B can take all the values from 0 to 9. 0 into any number. 0. So if a perfect square is 0 whole square, if a unit digit is 0, on squaring, not only this 0, tens place is also 0. 10 square 100, 20 square 400, 30 square 900. A perfect square ends with even number of zeros. A perfect square ends with even number of zeros. I hope the first conclusion is clear to you. A perfect square ends with even number of zeros. A with 1 whole square. 2 into any number, it is an even number. 2 into any number, even number. 1 square, it is 1. So the same unit digit will be written. 2 into any number, it is an even number. 2 into any number, it is an even number. Now see here. 2 into any number, it is an even number. 7 square is 49. 9 I will write 4 carried. 4 is an even number. Even plus even, it is also an even number. 2 into any number, even number. 8 square is 64. 64, write down 4. 6 carried. 6 is even. Even plus even, even. This is 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 always 0. 5 square is 25. 2 into 5, it is 10. Any number multiplied by 10, unit digit will be 0. 5 square is 25. 5, 2 carried. What is 0 plus 2? 2. If you see 2 into any number, even. 4 square 16. 6, 1 carried. Even plus 1, it is odd. 2 into any number, it is an even number. 6 square is 36. 6, 3 carried. Even plus odd, it is odd. One important conclusion. Now see here. A perfect square. What are some of the very, very important properties of perfect square? I hope the first one. A perfect square always ends with even number of zeros. A perfect square always ends with even number of zeros. I hope the idea it is clear. Next one. A perfect square tens place is odd. A perfect square tens place is odd only when the unit digit is 6. A perfect square tens place is odd only when the unit digit is 6. Only when the unit digit is 6, tens place will be odd. See here, 4 square 16, 6, 1 carried, 1 plus even, it is odd. Next one, a perfect square, tens place is 2. Tens place is 2. Only when unit digit is 5. A perfect square, tens place is 2. Only when unit digit it is 5. Only when unit digit it is 5. Make a note of these 3 important key points. When we are solving problems, I will discuss in detail the importance of it. These 3 key points, just not in writing the key points, the best way to learn mathematics is understand all the possible unit digits. We can range from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here also it is 2 into any number, even number. 9 square is 81. 1, 8 carried. 8 is an even number. Even number plus even number. We first discussed the square of a 2-digit number, then we are getting into a 3-digit number. Sir, should we use a plus b plus c whole square? First doubt. Are there any better ways to solve the problem? Next one. Sir, we discussed a plus b whole square. Are there any important properties that can be derived from these logic? Definitely yes. 3 important properties. A perfect square always ends with even number of zeros. A perfect square always ends with even zeros. A perfect square tens place will be odd only when the unit digit is 6. Third one, a perfect square tens place is 2 only when the unit digit is 5. These are must and should know properties related to perfect squares. There were some original questions like, how many 4-digit perfect squares are there where the first 2 digits are equal and the next 2 digits are equal? You can solve